So on number 9, I can factor out a cosine squared beta. So I'm going to take that out, cosine squared beta. And so I end up with 1 plus tangent squared beta. And remember, 1 plus tangent squared beta, this right here equals secant squared beta. So I'm going to write cosine squared beta times secant squared beta. Okay, so cosine squared beta times 1 over cosine squared beta. So this and this reduces and you end up with 1. Number 10 is, I'm going to factor the numerator. So secant x plus 1 and secant x minus 1. Denominator is secant x minus 1, right? So this factor cancels that factor, and you are left with this. So something similar on number 11. Numerator is difference of squares, so you get cosine theta plus 2 and cosine theta minus 2 over cosine theta minus 2. So this factor cancels with this factor, and we're left with this. So 11 and 13 could be seen as quadratics that we can factor. So let me set this up. So this would be like this. So the square root of tangent to the fourth, well, it's not theta, but we'll put tangents, would be tangent squared plus 1 and tangent squared plus 1. That's how you factor that quadratic, okay? Because it's like this. It's like if it was x to the fourth plus 2x squared plus 1. So think of it that way. You factor 12 like a quadratic like that, and then you end up with these two factors. Now, tangent squared plus 1 is equal to secant squared theta. So I'm going to replace each one of these. There's 2 of them that are the same factor, so there's 2 of those. And then combine those to multiply those 2 out, and you get secant to the fourth theta. And that's it. 13, same thing. Think of it as 1 minus 2x squared plus x to the fourth. Think of it like that. So when you factor, you have 1 minus cosine squared theta, 1 minus cosine squared theta. And so 1 minus cosine squared theta, if you go back to when we were doing number, number 6, well, 1 minus sine squared theta back then, on number 6, we replaced with cosine squared. So in this case, 1 minus cosine squared equals sine squared. For the same reason. Okay, because I'm looking at the Pythagorean identity and solving and moving the 1 over. I'm sorry, moving the cosine over. So that'll leave sine by itself. So now we just multiply these two and we get sine to the fourth theta. Number 14 is the difference of 2 squares. So you would say sine squared x minus cosine squared x times sine squared x plus cosine squared x. Okay, that's the difference of 2 squares. Okay, so this here equals 1. So this times 1 is itself, so you can leave the answer like this. That's as much. I mean, you could do more, but for we'll leave that for later when we get to the next chapter. For now, we could leave it like that. All right, number 15. You are going to factor by grouping because it's 4 terms. So this and this. So the first pair has cosecant squared theta in common. So you're left with cosecant theta minus 1. And then the next group, the next pair, I could factor out a negative 1. That leaves me with cosecant theta minus 1. Now notice how they have this term in common, so I'm going to take it out. So cosecant theta minus 1, cosecant squared theta, oops, put the square too early, cosecant squared theta minus 1. Okay, now what I can do now, I mean there's really not much more. I can replace, oh I forgot to put a square, huh? I can replace, let's see, cosecant squared theta minus 1, I can replace this one with cotangent. And that's as much as we could simplify it. There's not much we can do after that. 16 is very similar as to 15. I'm going to pair up. And so secant squared x is what I'm going to factor out of that one. So I'm left with secant x minus 1. Then minus 1 I can factor out, so that leaves me with secant x minus 1. Then they have this one in common, so I take that out. Okay, and then secant squared x minus 1. Now this can be replaced with tangent squared. So secant x minus 1 times tangent squared. And again, that's as far as we can go with that one. Number 17, notice how it has a cosine squared x in common, so I'm going to take it. That'll just work down here because this is too crowded already. So cosine squared x, 1 plus cotangent squared x. This here could be replaced with cosecant. And cosecant is 1 over sine. 1 over sine. So when you multiply across, right, you're going to get cosine squared x over sine squared x, which is cotangent squared x.